Scenario: a 5 kilogram cart experienced a force of 2 Newton on it so it can move across a rough horizontal surface. While moving, the force instantaneously increased to 10 Newton. Question: what happened to the system's kinetic energy when the force was instantaneously increased? Answer: it increased because force here being applied over a distance will equal to work. And we know that work is equal to the change in kinetic energy. If work goes up, then kinetic energy, or the change in kinetic energy, had to increase. That is the explanation on how it increased. So, the next question: what was the change in the kinetic energy when the force was instantaneously increased? Remember, we are looking for the force was instantaneously increased, and we are looking for the change in kinetic energy. That's our question mark. So, you have to understand that you have both force and distance, so you can compute work. Work is equal to the change in kinetic energy. Work can be defined by F times distance parallel. The force here, make sure you pick the right force. Remember, this is the force that was instantaneously increased. So the value here is 8 because before it was 2 newtons, then after it was 10 newtons. Okay, the change was your 8 newtons of force. That is what's being plugged in here. This is the work done by the change force. That's the reason why an 8 is used here. We have the distance of 2 meters here. This is the distance. Multiply together, we get 16 joules for the change in kinetic energy. This represents the amount of energy that went into the system as a result of the instantaneously increased to 10 Newton as a result of the 8 Newton change of force. Okay, it's not due to the 10 Newton force, right? It's due to the 8 Newton change of force because it went from 2 newtons to 8 newtons. All right, so there you go.